We can perform a series of transformations by multiplying the transformation matrices together. When we do this, we can come across a problem called the gimbal lock, which is where 2 or 3 planes align, so we lose the degrees of freedom. Let me show you what I mean. For example, if we would like to rotate an object with an angle alpha about the x-axis and then rotate it with beta about the y-axis, we can derive the transformation matrix by multiplying the 2 rotational matrices together. We can then perform the rotation by multiplying this matrix with the vertices of the object. However, this rotation method has a problem commonly known as gimbal lock. For instance, when rotating an object about the x, y, and z axis and the rotation about the y-axis is 90 degrees, it will end up with a gimbal lock problem where we'll lose 1 degree of freedoms. So no matter if it's alpha or beta, the object will only rotate about the z-axis and will no longer be able to rotate about the x-axis. This example app illustrates how gimbal lock is occurred. So the pink arrow is rotating about the z-axis by adjusting the angle beta. The orange arrow is supposed to rotate about the x-axis by changing the angle alpha. As you can see, it can only rotate about the z-axis. We lost 1 degree of freedom, and this is a gimbal lock problem. Gimbal lock occurs when 2 or 3 planes aligned. You can download this example Android app in the gimbal lock example program and try it out. Let's try and simulate the gimbal lock problem in our program. Open the Android Studio project and add the timer and timer task in the constructor of the MyView class. In the timer task, we want to spin the object about the x-axis. So we first define a variable called angle. In the run function of the timer task, we first translate the original cube vertices by 2, 2, and 2 and scale it 40 times in all 3 directions. Then rotate the cube about the x-axis with a variable angle about the y-axis by 90 degrees and about the z-axis with 25 degrees. We then translate the cube to 200, 200, and 0. Afterwards, we increment the value of the angle by 10 degrees and we schedule a timer task to trigger every 100 milliseconds. So this timer task object is supposed to spin the object about the x-axis in 10 degrees, and that occurs every 100 milliseconds. When you run the program, you should see that the cube is actually spinning around the z-axis, even though the angle rotates only varies in the x-axis. We have lost the ability to rotate about the x-axis. What do you think will happen if you swap the angle of rotation between the x and z-axis? If you do this, you can see that the cube is again rotating about the z-axis, but just in a different direction. In the next lecture, we'll look at using cotarians for rotation, which is the way to avoid gimbal lock.